Welcome to Study Park. Now we are going to discuss few topics and basics regarding HCF and LCM. What is HCF? HCF is nothing but highest common factor. That is the greatest number that divides all the numbers exactly, all the given numbers exactly is nothing but HCF. What about LCM? LCM is nothing but least common multiple or lowest common multiple. Its definition is nothing but product of the highest powers of all the prime factors that occurs in the given numbers. Okay, we'll understand these definitions clearly with the help of an example. Now consider this first example. Find the HCF and the LCM of 70 and 90. See, we are going to find the HCF and LCM of these two numbers. First, to find the HCF, we'll write down the numbers like this. Okay, now we'll write the multiples which makes us to bring this number. What are the multiples? It's nothing but 7 into 2 into 5. Able to follow? 5 into 2, 10 into 7, 70. We'll get the question, right? Now similarly for 90, we can write it as 3 into 3 into 2 into 5. See, 5 into 2, 10. 10 into 3, 30, 30 into 3, 90. Now, see the definition of HCF. The greatest number that divides all the numbers exactly. So, there is a common greatest number which divides the given two numbers exactly. See, common greatest numbers. Okay. See, 7 is present in the first one, that 7 multiple factor present in the first number but not in the second number. Okay, then 3, it is present in the second one but not in the first one. But in the case of 2 and 5, it is present in both the numbers. So the prime factors 2 and 5 can be the common greatest number. What is the answer? 10. So the HCF is equal to 10. Able to follow? Now for LCM, what's the definition? Least common multiple or lowest common multiple. For that, we have to write the given numbers like this, and we have to divide with all the possible prime factors that we could able to get the minimum value 1 and 1 for both these numbers. Okay, follow me. I'm going to divide by 5. So 14 5s are 70, 18 5s are 90. Now I have to divide this further. So 2, 7 and 9. 7, 1. 7 is not divisible by 9, so I'm writing it as it is. Then next 3, 1, 3. Again 1, 1. So I'm getting the lowest number 1 and 1. I have to do this for all the numbers. It should be 1 and 1 in the last step. Okay, till then we have to get the prime factors. Okay, see, now let us write this prime factors here. 5 into 2 into 7 into 3 square into 1. Okay, see, 5 power 1, 2 power 1, 7 power 1, 2, 3 square and into 1. So okay, no problem, 1 square. Okay, now see the definition. Product of the highest powers of all the prime factors. So we have to take all the prime factors and on one condition it should be the highest power. So I have to take 5 and his highest power is 1. And I have to take 2, its highest power is 1. I have to take 7, its highest power is 1. I have to take 3 but not 1, its highest power is 2, so I have to take 3 square. I have to take 1. Okay, now I have to multiply all this thing, so the answer is 630. Okay, so LCM is equal to 630. Able to follow? You can get a somewhat clear idea in the following examples. Now see, powers, HCF in powers. Okay, see, find the HCF of 2 power 4 into 3 squared into 5 cube into 7, 2 cube into 3 cube into 5 squared into 7 squared and 3 into 5 into 5 into 11. Sorry, there may be a question mistake here. 5 into this one is 7. Okay, now what I'm going to do is I'm considering this first one as x, second one as y, third one as z. Okay, now I have to write HCF highest common factor, so nothing but I have to write the common factors of x comma y comma z is nothing but, see, I have 2 here, I have 2 here, 2 here in the x, I have 2 here in the y, but I don't have 2 in the z, so it cannot be the common factor. I have 3 in all the 3 terms, right? So I can write the 3. Now I have 5 in all the 3 terms, right? So I can write 5. I have 7 in all the 3 terms, so I can write 7. I don't have 11 in the first 2 terms, I have only in the third term, so I can't write that. So it is not a common factor, right? So these 3 are the common factors of x, y and z. So what is the multiplication of this? 105. So HCF is 105. Okay, it's very simple, right? Similarly, in the case of LCM, I'm considering this one as x and this one as y, this one as z. So it is another example. Okay, the question is different. See, here I have to check the common multiples, but there is a condition. It should be the, see, it should be the highest powers. You follow? See, I can take, so the common multiples are 2, 5 and 7. Able to follow? So 2 is present in all the 3 terms, 5 is present in all the 3 terms, and 7 is present in the all 3 terms. Okay, so I can take 2, 5, 7 as a common multiples. Okay, but if it is in the HCF, I can directly multiply this, but it is LCM, so I have to consider the highest power. See, for 2, here 2 cube, here 2 squared and 2 4. Which one is the highest power? 2 power 4 is the highest power, so I have to take 2 power 4. For 5, here 5 power 1, 5 squared, 5 power 1. 5 squared is the highest power, so I have to take 5 squared. Okay, for 7, 7 power 1 is here, 7 squared is here, 7 power 1 is here. 7 squared is the highest one, so I have to consider 7 squared. Okay, now I have to multiply all these things. What is the result? It's 19,600. So this one is the LCM. I think now you got a clear picture of what is HCF and what is LCM, right? We'll solve further problems with the different methods. Okay, see, find the HCM and LCM of 4 by 5, 5 by 6 and 7 by 15. So this type is nothing but fractions. Okay, so HCF of fraction is nothing but HCF of numerator divided by LCM of denominator. Okay, similarly LCM of fraction is nothing but LCM of numerator divided by HCF of denominator. Okay, so this is the important formula which we are going to follow in this problem. Kindly follow. Now we are going to solve the first one. We are going to find the HCF of the fractions. So for that we have to find the HCF of the numerator. What are all the numerators? HCF of numerator. Numerator is nothing but 4, 5 and 7. See, 4 can be written as 2 into 2 in, okay, 4 can be written as 2 into 2. 5 can be written as 5. 7 can be written as 7. There is no other multiples possible, right? So there is no common factor. What can I do? I can write 1 in all the numbers. See, everything looks similar, right? So multiplying it by 1 doesn't change the question, right? So the common multiple factor here is 1. So HCF is equal to 1. Okay, now LCM of denominator. So how can I find the LCM of denominator? for that, what are the denominators? 5, 6 and 15, right? 5, 6, 15. We have to do it like this, right? So 5, 1, 6, 3. Now 3, 1, 2, 1, 2, 1, 1, 1. You're able to follow. So the LCM is nothing but 5 into 3 into 2. So 5 3s are 15 into 2, 30. Okay, so the 30. So the first one, HCF of the fraction is nothing but HCF of numerator is 1 divided by LCM of denominator is 30. So this one is the HCF. Okay, similarly we are going to solve for the second one, that is LCM of the fraction. LCM of the fraction, we need LCM of numerator. Okay, what is the numerators? 4, 5, 7. Okay, see, all looks different, so which means I will get 4, 5, 7, 5, 1, 1, 7, 7, 1, 1, 1, right? So what I am going to do is nothing but 4 into 5 into 7, right? So what is the answer? 7 5s are 35 into 4, 70, 140. Okay, so the first one is 140. Now HCF of denominator. So how can I find the HCF of denominator? Denominator is nothing but 5, 6, 15. Okay, so 5 can be written as 5 into 1 as we discussed earlier, and 6 can be written as 3 into 2 into 1 because we are adding 1 because no other way. 15 can be written as 5 into 3 into 1. Okay, see, 5 is present in the first one and the last one but not in the second one. 3 is present in the second one and the last one but not in the first one. So what can be the HCF? Is nothing but the 1. Okay, so HCF is 1. So what is the answer? LCM is nothing but LCM of numerator is 140 by HCF of denominator is nothing but 1. So the answer is 140. Okay, so it is easy, right? Finding HCF and LCM. Now we'll go for the decimals type. Okay, how to find the LCM for the decimal digits. So see, here we are going to ignore the decimal points. How? Like by writing like this. See, 24, so which means I have to add 2 zeros for other numbers to bring the decimal point to this point. Okay, so 24, 2 zeros, right? 120, and here 2 zeros, 600. So these are my numbers. So now I'm going to find the LCM. So 2, here 12, 60, 300, 2, 6, 30, 150, 2, 3, 15, 75. Now I'm going to divide by 3, 1, 5, 2, am I right? 2, 5, 1, 5, 25. Now by 5, 1, 1, 5. Now again by 5, it's nothing but 1, 1, 1. So what are all the numbers? Is 2 into 2 into 2 into 3 into 5 to 5. Okay, so what is the am I right? 2, 2, 2. So 3 2s, 1 3 and 2 5. Okay, so the answer is 600. Okay, so LCM of this decimals is 600. We don't have to worry about the decimals. We can just follow the normal method by ignoring the decimals by adding some certain zeros, corresponding zeros. Okay, now the next type, the HCF and LCM of two numbers are 63 and 1260 respectively. If one of the two numbers is 315, find the other number. So here it is a typical problem. The HCF and LCM is given and one of the number is given and we are asked to find the other number. How can we do that? There is a simple condition like HCF into LCM is nothing but product of two numbers. Okay, product of two numbers. So by applying this rule, HCF is nothing but 63 into LCM is nothing but 1260 into product of two numbers. Let the numbers be x and y. See, I know the one number is 315 and what about the other number? I don't know, so let it be 5. So now I am going to solve this. It's very simple, right? 63 into 1260 divided by 315 equal to y. Okay, so what is the answer? Y is nothing but 252. You get this by solving further. Okay, then go for the next problem. Find the greatest number that will divide 148, 246 and 623, leaving 4, 6 and 623 11 respectively. So nothing but reminders, right? Reminders, right? See, to find the greatest number that will divide exactly these three numbers and leaves these three as a remainder, there is a rule. We have to find the HCF of x minus a, y minus b and z minus c, where these are the given x, y, z are the given numbers and a, b, c are the reminders. Okay, just follow the case, follow the condition. 148 minus 4, right, comma 246 minus 6, comma 623 minus 11. So what are the three numbers? Is nothing but 144, comma 240, comma 612. Now I am going to find the HCF of all these numbers. Okay, so what are the HCF of all these numbers? Shall we find? So 144 is nothing but 12 square, right? So 12 into 12 is nothing but 6 into 2 into 6 into 2. So I can write 6 as 3 into 2, right? So 3 into 2 into 2 into 3 into 2 into 2. Okay, now similarly 240 is nothing but 12 into 20, right? So I can write 12 as 6 into 2 and 20 as 10 into 2. Okay, 3 into 2 into 2. So first 2 is over. Now into 5 into 2 into 2. Okay, now last one, 612. How can I write 612? 612 is nothing but, you have to know the simple multiplication, right? So 612 divided by 12. What is 612 divided by 12? Since 12 is occurring in the first two terms also, so it's nothing but 51 into 12. Okay, is there any other way that you can reduce this 51? I don't think so. So let it be 51 and let it be 51 into 12 is nothing but 6 into 2, which is nothing but 51 into 3 into 2 into 2. Okay, now I'm going to find the common multiplication, multiplying factors to determine the HCF. So what are these? See, I have 3 into 2 into 2 here, 3 into 2 into 2 here, 3 into 2 into 2 here. I don't have 51 in other two terms, so it is not possible, and these two also not possible. So the answer must be, HCF must be 3 into 2 into 2. So 3 2s are 6 into 2, 12. So the HCF is 12. It is very easy, right? So now we go for the last one. What is the smallest number which is exactly divisible by 36, 45, 63 and 80? See, it is somewhat similar to the previous question. It is the greatest number. Here we are going to find the smallest number. For greatest number, we got the formula based on HCF. So in vice versa, the smallest number, we should be following the LCM. Okay, so which is nothing but the LCM of all the four numbers. So LCM of 36, 45, 63, 80. Okay, now we have to solve this. How can I solve this? See, there has to be some way in which it can be solved in a easier way, right? So 2, 18 cannot be divided 40. Okay, 2, 9 cannot be divided 20. I think 3 becomes somewhat cool, right? So 3 3s are 1, 5, 2, 1 cannot be divided, so same 20. Now 3, 1, 5, 7, 20. I think now 5 will be cool. 1, 7, 4. Now 2, 1, 1, 7, 2. Now 2 again. 1, 1, 7, 1. Now again 7. 1, 1, 1, 1. So what are the multiples? I have 1, 2, 3, 4 2's. Okay, so 2 into 2 into 2 into 2 into 1, 2, 2 3's. 3 into 1, 5 and 1, 7. So 5 into 7. Okay, so what is the answer? I have to multiply 2 2's are 4, 4 2's are 8, 8 2's are 16 into 3 into 3 9, so 16 into 9 is 144. 144 into 5 is nothing but 720. 720 into 7 is nothing but 5040. So the answer is 5040. Okay, so you're able to follow. These are some of the important methods which we can expect based on HCF and LCM. Thanks for watching. Subscribe to my channel for more videos similar to this.